Hi guys, I'm bersipy and welcome to another game development experience. Today we are going to continue basically where we left, and we are going to continue the development of our 2D top-down shooter. And the game is basically is written in Python, totally Python. And if you want to check out the source code, is available on GitHub. I put the link in chat if you are watching from the live stream. Okay, so I guess let's just start. If we will. Okay. Just a bit of setup, but I think that we are almost okay with that. All right. So where we left off, I've added some point on our to-do list, so we can just. This is basically I'm just live streaming. I don't know what I'm doing, so be aware of that. So, first of all, let's start with an easy things. So, we need to reorganize in packages our Python modules. What I mean by that? I mean that, well, for example, so packages, package structure is actually really important because we'll define also our game logic in some way, in a visible way. So we need, for example, an entity package. I'm just live thinking. I don't know what I'm doing. So let's start with an entity. But entity is a ambiguous term because represents basically whatever impact the game from a game development standpoint. So maybe is not the right word. I don't know. Let me think. Well, let's just call it entity for now. Let's don't over. I don't want to overcomplicate the code too much. So let's move everything. We will have to basically change the imports, but this is not a problem. So entity maybe the enemy, the bullet, and the player. I think I made a mistake by accepting the Visual Studio Code import auto change because makes a lot of mistakes. So let's just skip changes. For now we have these entities. We will also need a manager class. Package, which by the way will be super overly abused, as you will see, because when you don't know how to call something, just add the manager to it, and it is okay. Okay, then we have the color constants, direction, ID generator, and main, which are actually, I think, fine. Okay, so let's just rename the import. So now we have something like colors should be fine, but bullet, for example, in bullet manager now is yes, is entity. Okay, this is right. So cool. Visual Studio didn't mess things up. Direction is good, color is good, and I think that we are almost done. Maybe okay. The main is not correct. And manager. Is redundant to call bullet manager manager after putting it in a manager folder, maybe, but I don't know. For now, it's good. We'll keep a note on that. So let's look at the to-do list. The reorganizing packages obviously will be a to-do that will continue forever. Let's just disable GitHub Copilot because is messing things up a bit. Okay, so now we have to let's check the game, by the way. Our 2D top-down shooter. Okay, bullet, no model name bullet, entity.bullet, which should be good. From bullet import bullet. Okay. Okay, so this is the game actually. The enemy is not moving, he's just generating itself somewhere, and which doesn't make sense obviously, but we will fix it. Okay, so the game is working. This is the important the important step. Okay, let's start with the bullet. The to-do list. We have to fix the enemy movement because enemy should basically move in a random direction. So move in random direction. Then after that we should basically limit the enemy movement inside the screen boundary, I think. So alright, and what now? I think that we are okay for now. No, okay, is the, by the way, is the below point, the point beneath. So when the enemy has been hit by a bullet, it should be destroyed, but we will care about it later. Okay, let's move the enemy. Enemy movement should be in the update method. We have also a move method, which actually doesn't do anything. Is not using the delta time, which is a problem, because if you remember, the player basically move using the delta time to be FPS independent, to be frame independent. Okay. So it's just, yes, speed times delta time. Okay, so let's implement it. Okay, now we are just, okay, we are calculating some distance between points. Something like that. Yes, this is the formula. We are basically, wait. We are elevating x by 2, which is the default, I guess. I'm not sure about that. We will specify it. Let me check, by the way. I will close it accidentally. Python. Okay. We have any default here? Default for power off. Oh, wait. Okay. Turn base the power exponential module. I don't know. Let's just specify 2 to be sure. Okay. So we have the distance between our position, the enemy position, and the destination, which is a random vector. There is a problem because the destination is actually generated just when the enemy is spawned, basically, is created. So we need to, but in the future, in the near future, we will need to move this logic, maybe in the move method. I don't know. Let's actually design the system in the to-do list. Okay, we move in random direction. We limit the enemy movement inside the screen boundary, but okay, moving in random direction, what does it mean, basically? It means that we need to get a new direction only if we have reached the previous one. Extra stonks. And what now? So we need something like a flag. But by the way, this is the only point, I think. Moving a random direction, okay. So let's just move it to a random direction. We have a distance. I don't know how to actually, we needed to interpolate between the, I don't even know if this is correct, by the way. Get random to the vector. Which, okay, this is good. We pass a range and it will just generate some random x and y for this range. Okay, for the start for the x and the stop for the y. Okay, this is good for me. Which is 0, 0 for now. Okay. So the update if self.destination reached, which is good. If we have reached the destination, we just select a new destination, which is already made, by the way. So we can just delete this, or maybe we can just check this point. And so this is not correct, by the way. We should use the screen width and height, I think, to get a new vector, a new destination. Now what we should do is to actually okay, move. Okay, let's move. So by the way, I'm not sure about the calculation, because what we need, let's open Excalibur, which has the last time drawing. So basically we are here. We are something like, for example, we have our enemy, and by the way, this is the same draw. So we have this situation. If I remember correctly, the reasoning was about okay, I calculate the distance, and then I just move the distance divided by some constant. We need basically to interpolate between the blue point and the red point, which okay, seems easy, but not for me now, live, extra live. So let's just think about it. Yes, so we will have an x and y for this one. So an x and y, because it's obviously a point. So we have the distance. We know the distance between the two points. We know how much distance we should take. Let me check. Maybe I've done something similar in another game. Now I'm really I don't remember, or maybe not. I don't know. Well. I don't know. Let's try. I don't know. I'm not finding the last notes. So okay, we need to move. We have the destination and we just need to move towards it. I'm not sure that the distance is needed, by the way. Let's check. to the game, move unit towards a point. Unit move something towards a point. Yes, this is one. This is the issue. Okay, the lerp, which by the way is I think Unity. Yes, Unity concept, which is interpolation, linear interpolation. I don't even know the formula. Which this is the formula, by the way. I think. Yes. Okay, let's create a function to interpolate two values, first of all. Maybe lerp. Lol. And let's replicate the formula, which is this one, basically. So we will need 2 points and a time, I think. Let's copy the lerp, the Unity lerp. Yes, we have the start, the end value, and the t, which is the time, I guess. Yes. So, for example, it is used elapsed frame, okay, which is I think the delta time, if I'm not sure about that, but who cares? Interpolation ratio. Okay, Unity has also a vector linear interpolation, so you can actually pass just 2 vector, and which is what I want, by the way. Vector 2 lerp. Yes. By the way, we are like copying Unity methods in our game, which is cool. Okay, we have 2 vector 2, and he is basically calculating. But maybe is far simple than I'm expecting. Maybe he's just applying the lerp function to each coordinate, which is probably what Unity vector interpolation is doing. Maybe we have also a Pygame interpolation. Wait, Python. Pygame interpolate. Yes, the vector class which I'm using. Okay. Let's see. Maybe we'll have a lerp. Yes, we have a lerp between 2 values, but maybe we have a lerp also for the vector. Just to... Okay, we have a lerp for the vector. Spherical interpolation. Who cares? Okay, we have the lerp for the vector. We just pass a vector 2. Okay, because we have... now I understand. So it's far easier than we thought. We don't have to reinvent the wheel in this case. Maybe we just have to move the... maybe we don't even need this distance, this Euclidean distance. We just need the linear interpolation between our position, which is the self position. Let's try. Yes. And the other vector, which is self.destination. And this will return a vector, which is the linear interpolation, but we need the time, I guess. Yes, the value, which is the float, which is the delta time. And now we need the... I think that is the delta time. So this is our actual immediate immediate step basically, which is weird to say. Yes, lol. Okay. We have our new basically our immediate step. This is the we can say something like immediate step, which is a new vector too, and we need to move towards it. We need to move, and moving towards this vector is basically like saying self dot position equal position dot lerp. So we are just moving forward for a step. Maybe it's just what we need. Let's remove the distance for now. By the way, this is the Euclidean distance. I don't think that we need just the distance in one value. We need to keep separate the coordinates. Maybe I'm getting it wrong. Let's just recap it a bit. Not Python, sorry. Yes, it's basically the length of a segment. So we are getting just the length as a value, as a single value. But we actually, for now, we don't need it. So maybe in the future, I don't know. Maybe in the future for the collisions. But for now is we don't care about it. So we have a new position. We can just say, well, we are actually already moving because we are updating the position, and then the object will be drawn at the new position. So we will be fine, maybe. Okay. Maybe I'm just not calling the right methods in our actual scene, which is in the main. Yes, I'm not calling, I think, the update on the enemy. Let's call it. All right. Yes, the enemy is moving now. Is moving actually pretty weird, in a pretty weird fashion. It's not linear. By the way, let's just say, okay, I realize something, that since we are creating a range that has as its boundaries the width and height of the screen, we are already fixing the issue that the enemy could just go outside the screen. So this is we have also fixed the screen boundary point basically. And let's just I lost the point. Wait. Software engineer have a bad memory, but they are good in structuring the notes, I think. So now we need to tell that if how can we determine if the destination is reached? Well, this is pretty simple. We just need to say in the movement, not in the move, sorry, maybe in the update. So if the destination is equal, I don't know if we can say equal. Maybe we have a compare. I don't know. If is equal to the position, we can just say that the destination is reached, basically. Yes, I know that I'm writing something not good, but we will fix it. Destination is reached, basically. and we need to get a new one. So we can just say we don't need actually a new a flag in this case. We can just say that if we have reached the destination, so if our actual position is equal to the destination, we just get a new one, and the next frame we will reach the new destination. Maybe in the future we could also add a timer, so we choose a destination only if we reach this timer, and we continuously move. Let's try again. It's super slow, by the way. Is asymptotically, he is trying to asymptotically reaching the point, which is weird. And obviously, I think that it will never actually reach the point. Why? I think that is not enough to pass the delta time. Is not enough. By the way, it's strange because it has like asymptotically like an exponential curve. So how to fix that? Maybe we need to keep the delta time to continuously adding the delta time. Let's search. Let's search. So maybe we already have something like that. No. Wait. I don't know, bro. Let's check. I can't find a solution now. So okay, we have no lerp here. Seems. By the way, I'm not taking care of the position here, which is sorry, of the speed, which is totally wrong. Okay, because we need to move towards the destination, but by interpolating my actual position, maybe not the actual position, but the lerp. We need to multiply the position times speed. I don't know. You know, guys, this is the good things about the live, no? Since this is a live, I'm just reasoning. I'm just getting crazier on stuff like in normal life. So, but we will make it happen. So we will make it happen. So RTS unit movement 2D. 2SD 2D. Click for grid movement, but this is not a grid, maybe. Well, a star, I don't care about pathfinding algorithm. No, this is not a possible solution. Nope. So, because we are actually. So what are we doing? By the way, we are actually calculating the next frame position, which is something like. So if we are here, oh, this is maybe too much. Okay. If we are here, we are basically calculating in the next frame how to reach a new point, which will be, for example, here. But the issue is that we are taking into consideration just the delta time. The delta time which will compensate for the lag, basically, but will not take into consideration the velocity, the speed. So I think that what we need is to multiply the position times the speed, like we did for the player. Yes, the speed times delta time, which will complicate the formula. So let's try. We don't have to get it correctly the first time, so we can just do self dot position. We need to multiply the vector. I don't know how we did for the. Yes, we did the speed times delta time, but maybe for the bullet, because we have a vector. Yes, we have a direction which to solve the Pythagorean Pythagoras theorem. We are normalizing it in place, by the way. Okay, so we have we don't have a direction here because we don't care about a specific direction. We can move in any direction we want. So not just positive y, negative x, and so on. In this case, we can just so we are multiplying basically our speed times delta time. Basically, that's it. That's basically it. The direction is a vector. Okay, so multiplying a vector by a number, just multiplying all its coordinates. So what we can do is to say self dot position is equal to. I don't know if we don't actually need the maybe we can just multiply the returned vector times the speed. Let's try that, by the way. I think that this is not correct, but we will see. In fact, we are not actually because we are multiplying the destination, basically, also doing like that. We are expanding the real destination. The destination is the same, but the movement that we are doing to move towards it is actually modified. So let's just delete the self.speed. I think that we need to multiply position times speed, maybe. Maybe is enough. I don't know. Nope. I don't know, guys. See, guys, I'm learning. Just learning. As you all. So we have point A and point B. we are interpolating, so we are basically getting the next immediate point to reach. Maybe as soon as we get this new point, maybe I've got an idea. This is the immediate point to reach, basically. Immediate destination. So what we're gonna do? We can say, so how we can move something? We can just multiply the position. We need to add the movement, basically, okay, which is speed times delta time in our case. So we needed to add to the immediate destination the movement, if I'm not wrong. No, okay. I don't know. So we will be, if we didn't have the destination to the interpolation to calculate, we could just make something like that, and we will be fine, basically. But we don't have a destination. Let's try it just for fun. Okay, it's not working, obviously. Now we can add a float. We are not using a vector here. Yes, we are using a vector. Because movement is a vector itself. Yes, is direction times. Okay, is a vector. So we'll need to add a new vector, basically. So maybe there is a smarter way to do it, but who cares? No, wait, what I'm doing? Yes, I think is correct. Is the direction, which is just to remember, is just a flag, no? Is 0, 1, minus 1. So it's just a flag. 0 is nothing, minus 1 is one direction, and 1 is the other. Here we don't have a direction in the enemy. Let's try it. Okay, he's moving too much, because we are basically okay, now we are just moving the enemy, which is correct, by the way. What speed are we assigning? No speed, which is 5. Well, 5 is a bit strange, because if the player has something like okay, has 6, how does the enemy move so fast? It has a 5. By the way, let's remove the default values, because we are just messing things up, confusing the design. Let's just require a speed for the enemy, something like 4, which should be slower than the player. Okay, now makes sense. Times 100, yes. So we have the movement. We needed to find a way to interpolate. I don't know. For me, it's not intuitive. So we are basically getting this last point in our calculation. We needed to add the speed to for reaching the destination. Let's check. Maybe this is the right question, I don't know. I don't think that... wait, what is this? R language. Let's start from the beginning. Maybe I'm making something wrong. I'm a beginner, guys. Maybe this is the right... Nope. Let's check this guide. Nope. Nope. Okay. A vector. I'm not sure, guys. No, this is far away than we are. I don't know. So here we are basically moving an object to a direction, a random direction. I think it's not the same, right? Maybe it's the same. Yes, it's the same direction. Yes, because we are increasing x and y with the same value. Makes sense. By lerping, we are basically applying the new x and y to our object. So we are basically literally applying the new coordinates. What we need maybe is to add the immediate destination, okay, to our position, which is which is the way to moving the object to the destination. But we also need to add the movement. Maybe, I don't know, maybe I'm just overcomplicating it. Let's try. I don't know, maybe it will work. But I think that I already did something like it. Let's check. Yes, the same issue as before. Because immediate destination is a vector. Okay, yes, because movement. Okay, no, I'm just. Okay. And no entity on the screen. Right. I don't know. Okay. Let's watch a tutorial at this point. Mike's code.
Hello there and welcome. In the exact 70 and we array cast and
Okay. He has also physics. Okay, he's setting the but this is by the way 2D. Code Monkey, I think that has a good tutorial on RTS movement.
get the unit RTS component.
Okay, he's using the collisions. By the way, this the destination for his code will be the mouse click, I think.
Awesome. Well, we're going to
Yes, we have the start position. Yes, current mouse position. By the way, this is the controller. I don't know. Okay, no, is the entity controller, I think.
various modules that X and the current mouse position.
So he's doing the left mouse pressed. I don't know a shit about Unity, by the way. Math float, I guess. F stands for float. Dot minus. So he's actually trying to get the minus between the x, the start and the destination. He's calculating the distance and creating a new vector with it. Okay. With the lower and upper right. He's getting so the two vector. A vector which okay, are the same. Lol. Are basically the same. Just the minus and the maximus.
Position X. Okay, let's test. Okay, so here we are, and the selection
Yes,
area
this is
starts off
the movement.
Okay. Now I click here and drag, and yep, there you go. There's a selection area perfectly fitting the correct position.
Or maybe it's just
Now I
the
can
selection
drag from
rectangle.
left to right and
Holy
right to
crap.
down.
Don't know.
And if I go and I select these two, yep, there you go, correctly select. All right, awesome. Now let's just make the selection area on top and tint it in green. All right, so here it is. Now it's tinted in green and it shows up on top. All right, awesome. So here we have our nice selection area. So now that we can select various units, now let's give them some orders. So let's give them a move order. Now here in the unit game object, the setup for this unit is based on the modular character controller that I covered in a previous video. So here you can see the various modules that this character has. So it has a move velocity and a move position direct component. We're going to use this module, which will take our character and move it to a position directly. And we're just going to call this function. So on our unit RTS script,
Wait. Okay, so he's calculating the move position is a vector. So transfer dot position is a vector, which should be the actual position, I guess. So move position minus transfer position, and he's normalizing the coordinates. Okay, and he just returns a vector 0. Okay, so he's actually calculating the next step as I'm doing, I guess. and if the destination has been reached, he's just returning a new vector with 0. So I guess that this will be the velocity. The velocity to move the object.
And we're just going to call this function. So on our unit RTS,
Let's watch.
Let's do a public void public move to. So we get the component of type move position, and then we set our move position.
Okay.
Again, go check out that video, which covers in detail how we made this nice modular system. So all we need to do is.
By the way, this is a cool design. I will probably have to study it.
In this case, input get mouse button down on the right mouse button, so button 1. And in here, let's cycle through all of our selected units. And we're simply going to tell them to go towards the mouse position.
Okay, this is the mouse selection.
Alright, so just like
okay, move to.
So let's test.
So,
and in here, let's
basically,
down on the right
he's actually setting the destination and moving the calling the move to. Move to is this method, so which calls the set move position of its iMove position interface. So let's check it before. Set move position. All right.
Character move it.
He's just assigning the move position. The movement basically is in the update, I guess. Yes, set velocity is the set velocity. Where is the set velocity, by the way? I don't know, man. He's actually doing utilizing his framework, I think. Maybe I'm just misunderstanding it. But I'm not sure that will help at this point. Yes, by the way, I've realized now the problem with the lerping. Because since we are lerping towards a point, we are as soon as we get closer and closer, these basically areas are just reducing. So we are asymptotically moving slower and slower, basically, something like that, to reach the point. So lerping is not the solution for move an entity. At least for me seems now. So this is the problem. And yes, lerping is not the solution. Let's change approach. What we can actually do. So since we know the distance, all right, let's remove the lerp stuff. Since we know the actual distance, what we can do is I don't know. See, this is where I'm getting confused, because okay, we know where we have to move, but how much x and y we need to move to reach this point, this red point. I don't know. So lerping is not a solution. I did something like it in a previous game. Maybe I can find it, because seems easy, but is actually not easy at all. It's a stupid problem, really stupid problem. But this is actually the part of the code that you made you make one time and then you just forget it forever. let's just so something like a selector, selection, the entity mover. I don't know. So. Okay, maybe I found something. Basically, so this was a move component which I did few months ago, and I totally don't remember how to actually implement it. So let's just read. Basically, we are passing a destination x and y and delta time. The rect is the I guess the actual rectangle, so the actual destination in Pygame. We're using a rect, I think, because the actual entity is a sprite. That's it. So we are basically calculating the distance. So we are taking the destination and subtracting my actual position. Then we pass it to a vector 2, and okay, we are calculating the distance between the coordinates and between the vector. Distance 2. Wait, there is a distance 2 method to a vector. Distance 2. Then we are getting the destination to move in this frame, which is just speed times delta time. Okay, cool. And if we have a distance to move. Okay, so distance is actually just to check if we have to move or not. That's it. But okay. Then we just pass the direct x and y to as our new rectangle position. Okay, let's try to implement it. So let's start again. As you see, guys, is sometimes is more difficult than others, but who cares? We are here to learn. So let's calculate the distance between the coordinates. By the way, this is not necessary now that I'm understanding. I'm remembering, actually, this system. We just need to calculate the distance. So let's just calculate in the distance. So self dot position, which is a vector, not the position, the destination at this point. So distance is equal to distance 2, and we can pass a vector 2, so we just pass self dot position. And now we have the distance. Vector distance 2 actually return a float. Okay. This is great, by the way. we are just getting the Euclidean distance between 2 points. Okay, so distance 2. Cool. Well, the distance to move is actually just self.speed times delta time. And then we just need to check if we have a distance. So if distance is okay, less than distance to move, right? Is less than distance to move, which is not maybe it was not correct because we can miss a step, but who cares? Okay, we just move. So we just say, okay, self dot position has the new coordinates. This is why I was calculating the coordinates separately because the distance 2 doesn't return a vector. So let's just calculate this is the distance. I don't know, let's just write the distance vector. Distance vector, which is self dot destination times not distance but what is squared, by the way? Don't know. I don't remember. Yes, I used the lerp, but is not my. Maybe I can just say destination minus position, and we'll just apply the subtraction to their coordinates. I think that this will work. Okay, distance vector. So if we have a distance to move, we just need to say that position is equal to the distance vector, if I'm correct. Well, this is weird. I don't remember why I did a different computation for the. Yes, it's like moving asymptotically to the point, towards the point. Don't know. It's like a lerp. This part. Yes, by the way, this is correct, I think. Let's try. Okay, it's not correct. Lol. Yoink. He's not moving, actually. And just checking the chat, guys. Okay, so distance to move. If we have a distance less than distance to move, we just apply the distance vector to the position, to the actual position. No, wait. This is wrong. Okay. This is when we don't actually has a distance. Yes. Yes, the real movement is in the else, actually. which is a kind of a lerp. Yes. So this is actually not the distance vector. We are not applying the distance vector. We are applying the destination. So the position is equal to the destination. Right. And the real calculation is actually okay. We need yes. Let's take the code again. We need to say something like the x is delta x, so the actual Euclidean distance over the x coordinate times distance to move divided by distance. Yes, by the actual distance. The distance to move. Okay. Yes, it's like a lerp. Okay. So we are actually. Okay, this is for all the coordinates. So we can say just something like x is equal to, yes, to the delta, the Euclidean distance. So delta x is equal to yes, is not the Euclidean distance. Is actually just the distance. So is the self dot destination dot x minus my actual position x. And this is also true for the y. All right. So here the destination will be delta x times the distance to move divided by the actual distance. Okay, this makes sense. And the y is the same. And now we can just apply the new position. I don't know if we can just maybe we have to do the new vector. We have to assign a new vector. So x and y. Okay, let's just check it. Yes, he's trying to move, but he's actually stuck in 0. So we have the distance, the actual distance between the two vectors. We have the distance to move, so how much movement we need to apply to our coordinates. Now we are getting the distance between the coordinates, and if we have enough distance, if the distance to move is greater than the distance, we just stop. If we need other blocks of distance to move, we just move. So we go in the else block, and here we are just calculating the the dx times distance to move divided by distance. Yes, he's making also the yes, because I'm not increasing the actual coordinates. But wait. Okay, this is wrong actually, because I needed to keep the state between each frame. So I needed to do something like this. Super. Yes. Okay. Now it's working. It's actually working. Guys, took quite a bit, but this is the good about the live, the good and the bad about the live. Just reasoning. So now we have an enemy that is moving. Let's just commit everything. Enemy now move. Alright. The good and bad about the stream. Cool. And so what? Now we need to... let's check the to-do list. When the enemy has been hit by a bullet, it should be destroyed. Let me check. Okay, let's implement it. Now we will need to check for a collision, I think. So we are drawing a rect, like manually now. The good things about a rect is that I think that has something like yes, some collide utilities that are ready to use, like collide rect, I think. Yes. So to take advantage of Pygame ecosystem, I think that we need to convert our entities basically in sprites or a class that has a rect basically. So we can just check with the rect if we are colliding. This should be simple, but wait. So how to implement it? By the way, we need to check between the bullet and the enemy, but obviously not on the enemy. We need to check the bullet. Let's try with the bullet. So, and we need to do it every update, I think. We need to move and then to check. And to check after the movement if we hit an entity. Okay, let's try. Now we are not implementing any system to do it, but you know, in the future maybe. So we can just say we don't have a rect. We have many options here. We can create a rect for this entity. Let's try. What the rect module has? Okay, the class. So the rect doesn't require any. Oh no, okay. It require left top with height. Left top is a position. With height is actually our size, our radius. Maybe even the circle has a... Yes, has a collide. Because the circle is returning a rect. So maybe you can just say pygame.circle. No, maybe I'm confusing. Maybe the rect... maybe I'm confusing the rect with the circle, because I don't know. For me, the rect is an area on the screen, so we can just let's try circle maybe. Nope. What is the difference? This is actually the class, the right class. But this class doesn't have a... no, yes, it has the collides utilities. So we can just say, okay, we have a rectangle. The problem is that maybe it's not the smartest way to do it, but let's try. We say, okay, we have a rectangle with default values. Left top with height. Let's check. Circle collision. So this is a common problem, I guess. Pygame.mask to create a collision mesh for your object. I use the mesh to do collision detection. In more detail, create an image file, okay. Set the color to transparent. Import the image. Create a mesh. Profit. Okay, no, this is too complicated. I don't know. What can we do? Because the rect is obviously a rect, and it required the characteristics of a... Wait, I'm getting confused. Rect is not actually a visual rect, it's just an area. So we need to define... is a collision box, basically. I don't know. Yes. This is just a collision rectangle. What we can say is far simple than we think. We need to take the actual radius. So we need to... so basically what we need is this. Let's take Excalibur. So we have something like a rectangle. We have a rectangle, but we need to check to draw the area. Basically, the rectangle, the square, is just the collision area, and the circle is our bullet for now. We need to draw the bullet from the center, which is basically this point here. Let's make it bigger as we can. Okay, this is not bigger as we can. All right. From here to there. So we needed to take the... I don't know, guys. I don't know the formula. From the center, if you add the radius, you get... you don't get this point. The top left corner. The top... yes, the top left corner. Let's check it. It doesn't make sense, this question. Yes, maybe I'm solving a problem that doesn't need to exist, because we can just say the rectangle is actually requesting for a left-hand top, and this is the problem now. You know what? Let's make use of Claude. Because this is a strange question. I don't know how to pose it. how can... Is there a way? Yes. The rectangle corner must be tangent to the circle. I don't know. Is center minus radius? Yes, but this is tangent. The square is not tangent. I don't know how to say. Tangent. The square is not tangent to the circle. The square corner is not tangent to the circle. I need to find it, knowing that the square contains the exact circle. Yes, we apologize you. So if r is the radius, okay, is that easy? Is 2 times radius. Okay, he is hallucinating here, I think, because he gave me the same answer as before. Let's just draw it. So let's say. By the way, we need to calculate it every frame to draw it. Okay, we will need the position.x minus the radius and y minus radius. Let's just draw it. Yes, on top of the circle. No, beneath the circle. Draw rect, and we pass the rect. I think that should be enough with the surface. Yes, yellow. Do we have other colors? Blue and okay, red and white. Let's say red. And I think we are okay. Let's try again by drawing the rectangle on top of the circle. Okay, we are not seeing anything. Yes, sorry, because it's the bullet. I'm getting tired. Argument must be rect style object. So, yes. No, wait. We need width and height. Okay, width, let's say... well, this is a problem. well, it's 2 times radius, I think. This is the size, by the way. All right. Let's draw the circle on top of the rectangle now. Okay, we needed to slow down the bullet, by the way, or the frame rate. Bullet 12, let's say 2, to analyze it. By the way, is perfectly correct. So the calculation is correct, actually. The rectangle, the collision rectangle is actually correct. So we can just say, okay. This will be our collision rect for now. By the way, if we just used a sprite, it will be much easier, because has already a collision. We don't have to calculate anything, basically. But now we are just using primitives geometries, so who cares. So collision rect, this is the collision rect. So if we have on the bullet the collision rect, this is wrong, by the way. No, okay, is right. We have a collision rect. We just need the collision rect here. Now the enemy. The enemy will check the collision rect. No, not the enemy. Maybe the bullet. Doesn't make sense, because I don't know, guys. Let's just move stuff around. So how can we create the collision between the projectiles, the bullet, and the enemy? Now we can increase the speed. So I don't know if it makes sense that is the enemy to check. You know, the best design will be probably something like an entity, that a manager that checks, something like a collision manager. The issue is that what the collision manager should do, should check every entity, or just the entity that's request. This is a design, by the way. I will add to the to-do list a new system, so the collision manager. But what the collision manager should do, we will see next time, I think. For now, let's just check it in the raw way, in the raw style. So now we have a collision rectangle on the bullet, and we can just apply the same as for the enemy, but it's far easier, because we already have a rect, basically, which is this one. So we can just say collision rect. And this should do. We have a top left, a width, and a height, which will basically be, by the way, a size at this point. Okay, no, we used the height and width just here. And so, what can we do, guys? We can pass the rectangle, actually. So self.collision rect. And should work, I guess. Yes, it's working, but we are not updating the right. Yes, because we needed to update now the x and y of the collision rectangle. We don't actually need the position anymore, I guess. Yes, we need to update the to update our collision rectangles, which is what will be drawn. I don't know. For me, it's not a good practice make something like this, but for now we'll just keep it simple. So we will just basically update the collision rectangle based on the position, the actual position. If we assign the position, we are actually making a deep copy or a shallow copy, or not a copy at all. I don't know. Yes, we can do something like it. We need to... Let's see. Pygame. How can we assign a vector 2 to a rectangle? Yes, maybe this is just the position, the x and y. What is fit? Don't know. What is move? Wait, what? What is move? Moves the rectangle, but what does it mean? Return a new rectangle that is moved by the given offset. Okay, so you have an offset. This is cool. But it's like basically a translation. Yes, so is the translation basically. We are just translating the rectangle. Okay, by the way, we can just I guess we can just use the move if it accept a vector. Yes, coordinates, which is I don't know if it actually works, but the vector has a x and y, which is a coordinate, right? Vector 2 coordinates. Let's check it. Okay, yes, it's a tuple, so it's basically a coordinate. Should work. Okay, so this is just not the best way, probably, code speaking, but who cares? We are just copying the position into the... Ah, by the way, we don't have to duplicate the code here, maybe. And we are done. Yes, he's not obviously moving. Hmm. I think that move doesn't work. Lol. Let's just create a coordinate. Let's try with coordinates. Coordinates. Where are coordinates? I hate this sidebar. Who cares? Just we will just pass the tuple. So we just say, well, this should move. Should work. But I've already tested, right? I'm getting tired. Okay, yes, I've already tested. Move doesn't return anything. Ah, oh, okay, is move. This was the issue. Lol. We needed to assign the new vector to the old one. That should fix. Let me check. Okay, is not has not fixed anything. So he's returning a rectangle. By the way, this is weird. This is weird. You know what? Who cares? Let's just draw the... No, okay, wait. We don't have to draw the... Ah, yes. I now I remember what I'm... Maybe... No, wait, what? Wait, what I'm doing wrong. Collision rectangle, which I'm updating it. I'm not sure about the move method. Okay, is an offset. Ah, yes, that's why. But, well, this should work, actually. Ah, yes, because it's an offset. You just need an offset. Let's just don't complicate it. Let's just say something position, and that's it. Rect argument is invalid. Yes, because the position is the vector 2. Okay. Let's make it the pedantic way. The good and bad about the streams, guys. Okay, now it's working. Now we have a collision rectangle for both, for the enemy and for the bullet. We need to check if they collide. We can do it on the enemy side, for example. Yes. We will do on the enemy side, because for now we are not actually deleting the bullets. Ah, no, yes, we are deleting the bullets with the bullets manager. By the way, maybe the bullets manager could check it for us. Okay, we need an intermediary, a collision manager. Maybe we can anticipate these arguments for for this experience. A collision manager. Okay, let's just create a collision manager. So let's define his interface. This is a design issue. We can just say collide, maybe. Wait. So the first question is where does this collision manager will be used? Where does this collision manager will be used? In the bullet, in the enemy, or in the scene? Probably in the scene, but just guessing. So in the scene we can create a logic and saying something like wait, I don't know, maybe on the bullet, because it's a bullet logic, but then the bullet should have a way to ask for the enemy, for the hitted enemy. Maybe this is a static method. We can just say rect A and rect B and just return. Let's import Pygame. Let's make it in the naive way. So we can just say this is a Pygame rectangle. We can just say rect A dot collide rect with rect B. This is the naive way, but this is we are supposing that this class will be used in the scene, because the scene is the only place where we have access on on all the entities, basically, for now, by the way. Okay, let's try to use it on the scene, but the issue is that we have a list of bullets. Maybe we can just pass the, I don't know, just thinking. Yep. We can just say if the two entities collide, we just apply some logic. But there is a problem. For now, we can just check for a single enemy, right? For example, if the enemy that we have instanced in the scene collide with any of the bullets, we can just delete the enemy. Let's implement it and let's see. Let's make it happen. Who cares? Happens, sorry. Okay. So we can just say we are already iterating through every bullet, right? To draw the bullets. Yes, in the bullets manager. So we don't have the list exposed in the scene, actually. Well, this is already an additional layer that will just maybe we can just use the collision manager on the entities managers that will actually need to check for collision. Maybe this is the right way. So we can just say in the ballet manager, I don't remember if I imported the, okay, no, not yet. We can just say in the ballet manager, yes, probably the entity manager will be better, but let's check the ballets manager. I don't know. From manager dot collision manager, import collision manager, and now we say here, we can just you know what, so here we are clearing the ballets that has a time to live expired, basically. So this method is a little bit ambiguous because he's actually cleaning the expired ballets. Holy crap. Exactly. So, the question now is, where do we need to put the check? The check if the collision is happening. The check probably should be in the update method. See, this is an issue, by the way, because if we keep an interface on the collision manager that needs two entities to check the collision, we are actually we need that the ballet manager we need that the ballet manager knows about the other entities, which is wrong, totally wrong from software engineering design. The collision manager should be not a static, maybe also a static class, but a third-party citizen, basically, that will take the entities himself. So itself. So if we are using the collision manager in the ballets manager, we need the ballet manager to know about the enemy, which is wrong. So let's change everything. Let's create a getter on the ballets manager to check to get all the active ballets. So we can say maybe a property. Yes. By the way, the ballets should not be exposed. I think should not be exposed. So we can just rename them as private. And create the relative property. So property just the getter, no setter. So we are limiting the modification, the external modification. Okay, this should work if I'm not missing something. So we have the getter. We can just instance the instance. We can just use the... Let's create a new package called scene. And let's move the main into the scene. The main will be our maybe test level. Yes. And let's add a new layer to our application. So Markdown. Python U. Lol. Okay, now we have a main. Main will just run will just say game.run, I think. Let's just doing something like that. So if name is equal main, let's just run the game. Well, we can just keep the main. We can just say something like that. Bam. And we are cool. So we can add logging, something like that in the main in the future. Let's create the main class, the game class. So the game class will actually take care of the state of the game. So where we are in the game, in the main menu, in the level 1, level 2. Let's implement it. So this class will has probably an active scene or an active state, maybe a state that we can associate to a scene, to a particular scene. Yes, we will need also states. Game states maybe is more clear. So we probably should create a utils or maybe a misc, because color, direction are all like utilities. Also id generator is a utilities. Yes, let's move it. Let's move them here. And then we have let's create the game state. Which has, for example, a main menu. Let's call it just menu. A main menu. Do we actually need a string or maybe an enumeration? Probably a string is good, because is a value that basically tells you something. But let's just keep it. We will leave the menu as an example, because now has no association, has no logical association. So test level. The game. So the game will has probably a state, an active state. The default will be the test level for now. And let's create a run method that will be called from the outside to run the game. So we needed to associate here the scene with the state. We can say something like if self.state is equal to game state dot test level. We can just instance and run the test level. By the way, we need also to change the state. And this will be a game loop, so we need also to take care about the... I don't know what we have to put here, but we'll see. Let's create the loop now. If this the state will be, we will instance our scene, our test level. Ah yes, this is the utils now. Okay, color has to be utils. Should work. Okay, we needed to import our scene. This is just a design, but we can improve it in a second time. Another problem is that here we don't have a, actually we don't have a class. So let's create a class. We can just call it scene probably. No, let's call it with a specific name. Probably is better. So basically it will have a run method with all this stuff inside. We needed to probably to remove the delta time from here. Also the screen. Let's move it. Let's move these settings in the game constructor. Actually, let's import Pygame. And let's instance the test level. And also let's run it. Because, you know, we don't care about the instance of the test level. We just care about what test level will return. If we return something. Let's import also the constants. All right. Now we need, for example, here probably is already working now. We just needed to implement the run method, but to check the run method, we also needed to move the frame rate outside. Outside, actually. Our game will have a single frame rate in throughout the entire application. Now a question occurs. First of all, we need to pass the screen here, because obviously the screen will be one dependency for each scene. Obviously, because so each scene can refer to it. For example, to draw something specific and so on. Okay, which is a surface. So basically, the design here could be something like we have a main game. We have the game. The game contains the actual loop, but is not the game loop. Alright. Is just a loop that iterates through scenes, through states. Inside each state there will be a proper game loop. So we basically need to pass the screen, but also the FPS to each scene, so we can centralize the FPS handling. Let's define the FPS. Maybe not, maybe as a constant, you know what? But let's use it here. Let's pass the FPS. Right. So now we have the FPS. Let's use it properly, by the way. I was missing the parentheses. Let's pass it to the constructor. So we have a class that has configurations, global configuration, class configurations. So instead of run, we could probably say create the constructor, which will have these characteristics. All right. Self.screen, self.fps. Now, so the loop, our scene loop, which is not a game loop basically, is just our scene loop now, is just about what? Is about probably yes. It needs to take care about everything now. So the screen, the drawing. But now, how can we actually change the state? Change the state of the game. We need a quit state to quit the game. So in the game class, we can just say if set self.state here in this iteration is equal to game state dot quit, we can just quit the game by doing what we are now doing here. Just say this. Obviously in the future we will make a class probably. Okay, now we need, if we want to quit here, we just return the game state. So game state, as you may understood, is a dependency throughout each class, which is not a problem at all, actually. So yes, we need to quit. Okay, the space will spawn a new bullet. And now we can just clear a bit our game loop, actually. Because here is the game loop. So we can just say, alright, no. Okay, this will remain like this. For now, we don't create a new method for this draw and update. We will just stay like that. The FPS obviously will be self.fps. What I've done... okay. This should work. Let's try. Obviously, is not working. Yes, because direction is now on utilities, I think. Yes. Let's correct the utils. Let's correct the errors. Yes, because run has to be static. Oh no, we need an instance because we need the self. So fame.run. Okay, now it's working fine. And you know what, guys? Let's just push it like that. Maybe restructuring package structure. Restructuring package. So we add by adding game state utils. All right. Now we have a much better structure, I think. All right. So collision manager. Now that we had the scene, we just fast forward the scene part. What we actually need is to say, okay, in this scene, I need a collision manager that will check if an entity is colliding with another. But what we can say, actually, in the collision manager, instead of just the two entities, we can just create a collide all, maybe, that will accept a rectangle, and a list. List of rects. Maybe we need, maybe typing is more appropriate in this situation. Yes, list. So we can say something like list of pygame.rect, I guess. Should be correct. I'm not sure about that, but should be correct. Now what we can say is we can just map this method. So we can say we can return if any of the, for example, the bullets. Let's just map the method. We need the function and the iterable. So we can just say rect dot collide rect with each elements on the other side. If any of them collide, any of the, for example, bullets collide, we just return true. This is useful just to check if maybe it's not collide all, it's collide any here. If something is colliding, basically. But it's not useful to check if a specific entity collide. So we can just say maybe you can just overload the collide method. Because, you know, what I want is a method that will just return true if no, wait. Maybe we have already all the methods, because we can just say, okay, if any method, sorry, any bullet is colliding with the enemy, let's just check. We change color, for example, to the enemy. So let's just check in the scene. So guys, now we are using also the right terms. Scene for scene, not main and so on. So right. Let's just import it. We should do it in the update, probably. In the update phase. Let's try that. If the enemy has colliding with the bullet manager dot bullets, with any of the bullets, we can just say enemy dot color. Wait, does the enemy has a color? Obviously yes, but let's improve the color list. Let's ask I don't know, some AI here. Generates other colors, please. I don't want to do it manually. Yoink, with double sauce. Okay, just basic ones. Boom. Alright, now we can just import, for example, don't know, we can just say if it collide, will remain yellow for some time. We'll just change from white to, not white, but let's just keep it yellow. Where we can update the color? Let's make it simple. Who cares? Let's try that. Cannot import blue from utils.color. We don't have blue. Alright, let's try again. Enemy object has no collide direct. Yes, because we are not passing the rectangle actually. We are passing the enemy. We need to pass not the enemy, but the in the scene, in our test level, we need to pass the collision rectangle. Well, here we need probably list comprehension. So bullet for bullet in. Yes, let's try again. Whoa, I just pressed space. Int object is not attribute collision rect. I've just spawned a bullet. What bullet is actually returning? Because I'm just I think that bullet should be a yes, a class actually. Let's check. Let's make it happens, alright, guys. So bullet manager. I'm returning just the bullets, which is a dictionary. Oh, a dictionary of type, a dictionary of bullet. It doesn't make sense. This we need the key and the value. The key is the ID, and the value is the bullet. So we need actually not the bullets, but the bullets dot values. I press space again. Now we have a tuple. Let's just print because you know values returns the view of the dictionary of its values, I guess. Sorry. So yes, because we have this tuple. Sorry. So we have not we have a tuple. A tuple, yes, let's remove this. A tuple from typing, obviously. We have a tuple, and the tuple is like bullet an int, which is time to live. Time to live is not an int, is a float. What? Wrong. Float. And then we have also the time. Time, watch. Is a float. Okay. Is a float. Which data type? Okay, this should be correct. So what we need actually, we need we have the values, which is a list of tuples, which is a tuple, sorry. No, a lit is a tuple, yes. Okay, I am just getting, I'm getting crazier and crazier. Now we need just the first element, just the bullet. So what we can do is to create a comprehension. We can say t of 0 for t in, and now we are getting just the bullet, I think. Yes, okay. It's not colliding. Yes. So wait, what happened? Let's try again. Is far difficult than I thought. Okay, this is weird. Let's reduce the enemy speed. This is freaking weird. Let's remove math. The speed should be, I don't know, something like, let's make it 2. Just 2. Alright. Is colliding. Wait, what I've done? He is colliding with the player actually. The collision is not actually working. Is working on the player. Is working on the player. If I just intercept the enemy, yes, the collision just stay. We are not updating the collision of the bullets, if I'm understanding correctly. Because if I spawn the bullet just where the enemy is going, yes, this is the problem. We are not updating the collision box of the enemy, the collision rect. It seems to me, but I'm not sure now. I'm not sure now. I'm not sure because we are actually not of the enemy. Wait, of the bullet. This is the problem here. We are not updating. Right. Okay, we just need to update here. Is a vector, right? Why he is not suggesting me anything? It's a vector 2D .x, right? Yes. So we can just, it's not suggesting anything to me. Movement is a vector 2. Okay, because movement is a vector 2, obviously. Maybe we can just annotate movement. It's not important, but just for reference. Now we should have the, okay, now it's working. And we can do the same thing for the y-axis, y coordinate. So now should work. Wait. Yes, now it's working. Okay, guys, now we have we can just commit this. We added some colors, and we added we tested we implemented, I don't know, is a fix this? Maybe it's a fix. Fix collision update on bullets. And then Well, other part is just the other part is just a test, so we don't mention it. Okay, now what we can do. Okay, now we have something. By the way, guys, there are already 2 hours and 20 minutes. So in 10 minutes, I think that I will close the stream. So let's see what we can do in 10 minutes. Let's check the to-do list. Enemy movement has been fixed. When the enemy has been hit by a bullet, should be destroyed. Let's implement it. Implement this. Well, is probably simple. We need also here to create a manager, a new layer. Something like enemy manager. As you can see, we are abusing about the manager directory. So enemy manager, and will be basically like the bullet manager. So we'll has the same interface. We can say we can just copy and paste it, and also the import. Not a bullet, but an enemy. And instead of the bullet, okay, we just say enemy. We are being too specific again. Probably the cleanest way to design this will be to just create an entity manager, something like that. But for now, we will just make things works. We are in MVP basically. Okay, so we have an ID for enemies. We can spawn a new enemy. We can draw the enemy, and we can just update the enemies, and we can just clean all the enemies. Enemies. Now, yes, bullets maybe is enemies. And bullet ID is probably enemy ID. Let's check for a generic bullet. This will be enemies. Real fast, guys. Real fast. The system is the same. Probably in the future will be a base class. All these common logic between bullets and enemies. But for now, enemies here has a time to live, so we don't have basically to check for time to live. We have to check for if they have had collide or not. This is quite easy, I think. We can just say self dot has collide, which will be by default false. Is a one-shot flag. This, as you may imagine. So basically, the enemy has collide. Maybe this will be set by the external collision manager. Yes, something like an interface. We probably will need some interface system in the future, because as you can see now, we will be useful to have an interface in this situation. But who cares? So has collide, and we will just set from the outside. Let's just write a bad comment, a really wrong and ugly comment. So set by collision manager is totally wrong, but who cares? It's totally not wrong, but ugly. Let's create the flag here, and now let's just change the logic. So how can we implement it? We need flags, so then we can just check through the list of entities, of enemies, and check which one has this flag true. We can filter through them and just delete them. And you know what? Maybe is not has collide. Is probably has been killed, something like that. Oppure is dead. Let's call it is dead. Has dead. Has died. No, probably is dead is more appropriate. I'm just tired, guys. Sorry. So is dead. Doesn't make sense. That is the collision manager that set it. Let's check. Probably the solution is in the scene. Instead of changing the color, we just we need to iterate through enemies now. For enemy manager, enemies manager dot enemies for enemy in the list of enemies. If they collide, we just set the flag. So enemies manager has to be imported. Yes, is enemies. Let's remove the unused yellow. Okay, now we have the manager. And we have almost done. I think that actually we are okay. We need just to implement the clean old enemies. which now is killed enemies. Clean killed enemies. We don't need obviously the time. We just need to change this comprehension basically. And how? Okay, well, it's easy, I think. Is well, data is actually this is the object. So if the object dot is dead, if is not dead, basically, this should work, and is not working, obviously. The enemy is not been updated, maybe has not been updated. Ah, wait, this is not correct. Wait. I think that we need to change the logic here, because we don't want to write this every time. We just want that the class return a list of bullets, for example. Here we are getting the tuple. Ah no, okay, here we have, okay, no, this is correct. I'm getting tired. We almost done. We have almost done. A lot of things to check. We don't have to get crazy. Let's just print. Ah, because we are not appending, we are not spawning the enemy. Sorry. We are bypassing the manager. We need to spawn the enemy. So we need to say enemy's manager dot spawn with the starting position, which in our case, okay, this is a wrong interface for us. We don't care about all these informations. We just need the number. Well, we don't need anything actually. We just need the speed, which will be by default. Let's make it like 3. Oh yes, this change everything. This change like everything. We just need the enemy here. I don't know. For now, the enemy. So let's just change like everything. Just the enemy. So we have an ID object, so a key value pair of this type. This is not a tuple deconstruction. This will be just the enemy. And object, enemy D and the object. Okay, we can just simplify everything. Cannot touch as local variable enemies. Right. We need to update via the enemies manager. Yes, we don't have a tuple now. We can just return the list with its values. So no list comprehension, basically. Now it should work. Okay, has just stopped. Lol. Has just stopped because by the way, this is all a good signal for us. But because he's drawing the I don't know, bird. You know, it's just a good signal. He's not actually removing the enemy. Well, we just need we can maybe just simplify it even better. For enemy in okay, we are updating. By the way, it's weird because we are how is that possible? How many enemies does do we have? Let's just print them. Maybe not each frame, maybe every, I don't know. Every second. I don't know if this is the right way, by the way. Maybe yes, maybe not. I don't know. Yes, we are not printing anything. Ah, yes, because delta time is really little, actually. Yes, we need to normalize something like this, maybe. Oh, yes. Yes, now we have no enemies, but the screen has not been updated. We are, it's like we are not updating what we are drawing here. Wait. How is that possible? Because we are drawn the enemy. How is that possible? That the code has not crashed. Who cares? Let's say enemies manager dot draw self dot screen. This should work, hopefully. Okay, now it's working. Right. I don't know which bug caused it before, but who cares? Let's remove the accumulator stuff. Now we should be okay with the shooting part. So we can probably just check what we need to do the next time and close the stream here, I guess. Okay, so now we have implemented a basic shooting algorithm. Added def for enemies. Lol. Maybe we can create the next time the spawner as a system. And so random enemies. The next time we'll do the random enemies spawn. Spawn each time the enemy dies. Okay, guys. Hope you had fun and hope you learned with me. I think that I can close. I'm a bit tired now, so see you next time, guys. And I don't know. The name is bersipy, I guess. Hi, guys.